See, this is the test of atomic structure. Rather, I can say these are the very, very, very important questions of atomic structure. First few questions, they are from quantum numbers. So let us recall or revise quantum numbers. What are these? Quantum numbers. One second. Let me take pen. Now, what are the quantum numbers? Quantum numbers are the address of electron in an atom. Who gave these quantum numbers? These were given by Schrödinger wave equation. By solving this equation, we got three quantum numbers, N, L, M. And the fourth quantum number, S, basically is not obtained directly by solving its equation. It was indirect consequence of Schrödinger wave equation. Okay? This is very important question. Which of the following quantum numbers is not obtained as directly solving Schrödinger wave equation? Answer is spin quantum number. So what is N? N is the number of shell. Like N can be 1, 2, 3, 4 or 5. But N can never be equal to 0. Right? 1, 2, 3, 4. One shell is K shell. Second is L, M, N, O and so on. Like this is the nucleus in an atom. First shell, second, third, fourth, fifth. For this, N equal to 1. For this, 2, 3, 4 and 5. This is the fifth shell. So N represents the number of shell and also the distance from nucleus and energy. Energy of electron in fifth shell is high and energy of electron in fourth shell is lesser. Why? Because whenever electron is present at infinite distance, its energy is taken to be 0. As soon as it comes closer to the nucleus, what happens? Its energy decreases. So here energy is decreased to small extent. Further decreases. We can say the electron present in first shell has the lowest energy. So we can also say as soon as we move away from the nucleus, energy of electron increases. Yes, it's true, right? So it tells us the distance from the nucleus gone, principal quantum number. What is it? N. And also the energy of electron present in the shell. Next is the L. L is known as azimuthal quantum number. Azimuthal quantum number. What does it tell? It tells us the number of subshells in a shell. Like if n equal to 1 means we are talking about K shell. How many subshells are there? L. The values of L are from 0 to n minus 1. As n equal to 1, L equal to 0 to n minus 1. So 0 to 1 minus 1 equal to 0. So the value of L is 0 only for first shell. Or we can say number of subshells in first shell. The number of subshells, how many are these? These are 1 only. The value is 0. In second shell, 2 subshells are there. Value 0 or 1. In third shell, 3 subshells are there. 0, 1 and 2. In fourth shell, 4 subshells are there. 0, 1, 2, 3. In fifth shell, 5 subshells are there. 0, 1, 2, 3 and 4. What is the name of L equal to 0? 0 subshell. That is S. For 1, it's P. For 2, it's D. For 3, it's F. For 4, it's G. One question which is in your NCERT's bag. In which shell G subshell is started for the first time? Answer is fifth shell. In first shell, only S subshell is there. In second shell, 2 subshells are there. One is S, one is P, like this. First shell, only 1 subshell is there. We call it S. It is 1S. In second shell, 2 subshells are there. One is 2S, another is 2P. In third, 3 subshells are there. It is very interesting phenomenon. If I'll ask you how many subshells are there in 10th shell, answer is 10. The number of subshells is equal to n. Whatever the name of the shell is, so many subshells are present. So it is 3s, 3p, 3d. In 4, 4s, 4p, 4d, 4f. Like 5s, 5p, 5d, 5f, 5g. Right? So these are the subshells. S, P, D, F, G are the subshells. K, L, M, N are the shells. Now, M represents orientation. This is the another name for orbitals. We call orientation also instead of orbitals, orbitals. M will tell us how many orbitals are there in a subshell. Like in S, only one orbital is there. In P, three orbitals are there. In D, five orbitals are there. 1, 2, 3, 4, and 5. S is the subshell. This dabba is an orbital or orientation. In each dabba or orbital, two electrons are accommodated. One electron has plus half spin quantum number. Another electron is having minus half spin quantum number. This whole is known as a subshell. Point is to be noted. If we are talking about P subshell, means we are talking about three dabbas, three orbitals, means 6 electron, and this is one orbital. We call it px. Another is known as py. Still another is known as pz. Px orbital, py orbital, pz is also orbital, but p is a subshell, right? So total 6 electrons are accommodated in p subshell. This is d. One's name is dxy, another's name is dyz, dzx, dx square minus y square, dz square. I'm very much interested in the shapes of these d orbitals because there is one very important question on this particular topic. So let me clear all the drawings. Before starting question, you must know all these things, right? Okay. So the shape of S is spherical. Shape of P is dumbbell. What is the name of this Px? This is Py and this is Pz. Why? Because this axis I have taken X and this is Y and this tilted is Z. That's why it is Px, Py, Pz, and the shape is dumbbell shape. D orbitals, these are 5 in number. Like this. dxy, dyz, dzx. xy लिखेंगे तो बन जाएगा dxy. If we write yz, it will become dyz. If we write down x and z, it will become dxz, right? And this is dx square minus y square. Now the question arises, what is the difference between dx square minus y square and dxy? Their lobes are present at 45-degree angle to each other, right? What does this line indicate? What is the meaning of this line enclosed? It indicates the probability of finding electron is maximum here. Means electron यहीं इसी जगह पे गिड़िया मारेगा, बाहर नहीं जाएगा इस बाउंड्री से. तो बाउंड्री मीन्स इलेक्ट्रॉन विल रिवॉल्व विद इन दिस बाउंड्री, इससे बाहर नहीं जाएगा. उस बाउंड्री को ही हमने मतलब जब हमने इलेक्ट्रॉन फोटोग्राफी ली तो उसमें हमने क्या किया, ये देखा कि इलेक्ट्रॉन यहीं पे रहता है मैक्सिमम टाइम, तो हमने वो बाउंड्री बना दी, राइट? तो दोनों में क्या डिफरेंस है? 45 डिग्री एंगल का डिफरेंस है. एंड मोर ओवर दीज लोब्स आर प्रेजेंट अलोंग द एक्सिस, बट दीज आर प्रेजेंट इन बिटवीन द एक्सिस. दिस इज द मेन डिफरेंस. ओके, लास्ट इज डी जेड स्क्वायर. दिस इज डी जेड स्क्वायर. Out of these four, which orbital has no four lobes? Answer is dz square. All of these are having four lobes, and this is not having four lobes. This is having only two lobes and one circle. This circle is around x-axis and the lobe is along the z-axis, right? So we call it dz square. Okay. Donut shape. All of these are having clover leaf-like. After the class is over, go to the Google and search clover leaf. Exactly the same picture you will get. So all of these are having a clover leaf like structure, and the last is having donut structure, donut shape, right? Okay, this was all about the shapes and quantum numbers. Let us start our question. First question is, how many electrons in an atom have following quantum numbers? If n is 3, we will write down here 3. If L is 0, we will write down S, right? 3s can accommodate only 2 electrons. So our answer is 2 electrons. The question was, how many electrons in an atom have the following quantum numbers? N equal to 3, L equal to 0. It means we are talking about 3s. So S can accommodate 2 electrons. So answer is 2 electrons. How many subshells associated with N equal to 4? 4. If N equal to 10, 10. N equal to 6, to 6. The number of subshells is equal to the number of N. So, what are the names of the subshells? S, P, D, and F. Which d orbital does not has 4 lobes, dz square? And what is the shape called? Donut. Right now, I've told you it is donut shape. What will be the order of energy levels? 3s, 3p, 3d in case of H atom. The question is, arrange these in increasing order of energy or decreasing order of energy. Or we can say out of these three, which has the higher energy and which has the lower energy. Let me tell you, in case of hydrogen atom, energy is decided on the basis of principal quantum number only. 3s has a 3, 3p has 3, 3d has 3. So out of 3s, 3p and 3d in case of hydrogen atom, all of these are having the same energy because all of these are having the same value of n. In hydrogen atom, energy is decided on the basis of only principal quantum number. So answer is all of these are having the same energy, have same energy. The number of 2p electrons having spin quantum number s equal to minus half r. First of all, concentrate on this word 2p electrons. Total electrons in p subshell are 6 in number. Out of these 6 electrons, half will be having minus half. Half of these are having plus half spin quantum number. But it is asking about s minus half. The answer is 3. Out of 6 2p electrons, 3 will be having minus half spin quantum number. If the angular quantum number of electron is 0, in which orbital it is present? 0 is for L equal to 0, S. It is present in S subshell. Next is, one second, let me scroll it down. Okay. Next question is 6b part. A p electron can accommodate, orbital, sorry. A p orbital, not subshell. Every orbital, whether it is S, P, D or F, every orbital can accommodate only 2 electrons. A p subshell. Subshell means it is talking about all the 3 dabbas. We are talking about all these 3. The complete is subshell. They can accommodate 6 electrons. State Pauli's exclusion principle. Whenever this question is asked, concentrate on this dabba, orbital and 2 electrons. Whenever you think about the Pauli's exclusion principle, just remind this orbital having 2 electrons. And this is the definition. How? Each orbital can accommodate 2 electrons with opposite spin. This is the definition of Pauli's exclusion principle. Now the next thing. Why this exclusion word is included here? Exclude means bahar nikal do. Kisko bahar nikal do? It says if 2 orbital has 2 electrons with the same spin, then एक को बाहर निकाल दो, exclude कर दो. Basically, this definition or principle came from this concept. लेकिन इसको हम ऐसे भी लिख सकते हैं कि each orbital accommodates 2 electrons with opposite spin, right? एंड ये भी कह सकते हैं नो टू इलेक्ट्रॉन इन एन एटम कैन हैव द सेम सेट ऑफ ऑल द फोर क्वांटम नंबर्स। किसी भी दो इलेक्ट्रॉन के सारे क्वांटम नंबर सेम नहीं होंगे। ये ऑपोजिट स्पिन का यही मतलब है। सपोज both these electrons are present in 4s subshell. Just imagine. Then their n will be same, l will be same, m will be same, but the value of s is different. यही मतलब है इसका कि चारों क्वांटम नंबर्स, किसी भी दो इलेक्ट्रॉन के एन एटम कैन नॉट हैव द सेम सेट ऑफ ऑल द फोर क्वांटम नंबर्स। ठीक है, स्पिन तो कम से कम अलग हो गई होगा। सेकंड है कि इन एन ऑर्बिटल टू इलेक्ट्रॉन्स आर अकोमोडेटेड विद ऑपोजिट स्पिन। एक्सक्लूजन वर्ड का क्या मतलब होता है? इफ इन एन ऑर्बिटल two electrons are with the same spin, then take one electron out of the atom. Okay, next is an electron is in one of the 3D orbital. Give possible values of n, l for this electron. So the value of n will be 3. Whatever is written here, that is the value of n, and l will be equal to 2. Why? Because it is s, the value of l will be 0. For P, the value of L is 1. For D, the value of L is 2. Always, it is fixed. State Heisenberg's uncertainty principle. Now, the concentrate on the word uncertainty. What is uncertain? Position and momentum. एक साथ measure नहीं कर सकते इलेक्ट्रॉन के। अगर एक एक्यूरेसी से आ गई तो दूसरी इनएक्यूरेट हो जाएगी। इसे बोलते हैं अनसर्टेनिटी। किसमें अनसर्टेनिटी है? मेजरमेंट में। किसकी मेजरमेंट में? इलेक्ट्रॉन की पोजीशन और मोमेंटम की मेजरमेंट में अनसर्टेनिटी है। इसे हम ऐसे कह सकते हैं, वेन एवर दिस क्वेश्चन इज इन योर एग्जाम, जस्ट कंसेंट्रेट ऑन द वर्ड अनसर्टेनिटी। फिर यहां से दिमाग लगाओ कि अनसर्टेन क्या था? इलेक्ट्रॉन की पोजीशन और मोमेंटम को एक साथ मेजर नहीं कर सकते, वो अनसर्टेन है। सो इट इज इम्पॉसिबल टू मेजर simultaneously the position and momentum of an electron with accuracy. Why so? Because if position is accurate, momentum will be inaccurate. So mathematically, delta x into m delta v more than equal to h upon 4 pi. But for the sake of convenience, we don't take more than, we take equal to for the numerical purposes. What is the lowest value of n that allows g orbital to exist? Fifth shell has g orbital for the first time to exist. Using SPDF notation, describe the orbital with following quantum numbers. N equal to 3, L1. Just now I've told you if L is 1, it is P. So answer is 3P and 4F. Right? Define photoelectric effect. What is this? This is a metal. You allow one radiation to fall on it. Electron is ejected from its surface. Photo means, where it is, photo means light. Electric means electron bahar nikal gaya. इसी पे कंसंट्रेट करो, you will get the definition. It is the ejection. Ejection होता है बाहर निकल जाना. It is the ejection of electron from the surface of metal when radiation of suitable frequency falls on it. Why did this word suitable has been used? Suitable का मतलब होता है कम से कम, क्योंकि हर मेटल की अपनी अपनी एक एनर्जी होती है। सपोज इट सेज कि मुझे 200 किलो जूल एनर्जी चाहिए तो मैं इलेक्ट्रॉन बाहर निकालूंगा, तो ये रेडिएशन की एनर्जी फ्रीक्वेंसी इतनी होनी चाहिए कि जिसमें एनर्जी 200 से ज्यादा हो, कम ना हो। अगर कम होगी तो इलेक्ट्रॉन नहीं निकलेगा। दैट्स व्हाई द वर्ड सुटेबल इज टू बी included. So it is the ejection of electron from the surface of metal when the radiation of suitable frequency fall on it. How many angular nodes are present in 5D? The formula for this angular nodes is n minus l minus 1. N is 5 here. L for D, L की value 2 होती है, minus 2 minus 1. So answer is 2. Next is 11th question. 1 second. Fine. Come to the question number 11th A part. How many electrons in sulfur has n plus l equal to 3? N plus l equal to 3 is possible for 3 plus 0 combination, 2 plus 1 combination, 1 plus 2 we can't write down because the value of L can never be more than the value of N. So it is not to be written. Only we have got two values. One is for 3s, another is for 2p. In S total 2 electrons can be accommodated. In P total 6 electrons can be accommodated. But the twist is that in this question it is asked how many electrons in sulfur. It is not asking in all the atoms. It is asking in sulfur has N plus L3 means 3s and 2p have N plus L3. Now let us find out whether they are present in sulfur or not. So go for the configuration of sulfur. It is a double question. Examiner just want to ask you the configuration as well as N plus L value. Sulfur has 16 electrons. So the configuration is 1s2, 2s2, 2p6, 3s2 and 3p4. Right? 3s. Yes, it has 3s. कितने electrons है? 2. 2p. Yes, it has 2p also. 2 plus 6 equal to 8 electron is the answer. First of all, we have to find out N plus L value will be possible for how many subshells. It is for 2s and 2p, 3s and 2p. Then you have to write down the configuration of sulfur to find out whether they are present or not. Yes, they were present with 8 electrons. So answer is 8 electron. This is damn important question. Definitely must be there in exam. What is the difference between small l and capital L? Small l represents azimuthal quantum number and capital L represents the shell. Like first shell is K, second shell is L. So L is the name of shell and small l is azimuthal quantum number. Write electronic configuration of. Next question is 12th A. Write electronic configuration of Fe3 plus. Atomic number of iron is 26. First of all, you have to write down the complete configuration of 26. How? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. It is the configuration of iron. Now we have to remove 3 electrons. Why? Because 3 positive charge is there. Positive charge means electrons are to be removed. So remove 3 electrons. Electrons are always removed from 4s, then from 3d. So remove all the 2 electrons and one more from 3d. So this is the configuration of Fe3 positive. Right? First of all, you write down the configuration for iron, then remove 3 electrons. And electrons are always to be removed first from 4s. If both K and L shells are full, then what is the atomic number of elements? We all know. In K shell, only 2 electrons can be accommodated. In L shell, total 8 electrons are accommodated. The question is saying K is full, L is full. Total how many electrons are there? 10. 10 is the atomic number of neon. Right? So atomic number of element is 10 and this is neon. Write electronic configuration of copper and chromium. Both of these are the exceptional cases. How? Let me tell you. Let us take the configuration of chromium first. 24 total. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. It should be the configuration, but it is exceptional. Why? Because one electron is shifted from S to 3D. Why? Because 3D5 configuration is more stable than 3D4 because it is exactly half-filled configuration. So correct configuration is not this. It is ऊपर वाला will remain the same. नीचे आ जाएगा 4s1 3d5. इसको हटा दो and this is the configuration of chromium. Next question. Why did it happen? So as to attain the stability. Why? Because 3D5 configuration is exactly half-filled configuration of D and it is much better than 3D4. That's why one electron is shifted from 3D to 4s. Similarly with copper. Let us write down the configuration of copper. It is 29, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. It should be. But actually one electron is once again shifted from 4s to 3d9. It will become 3d10. This is the configuration of copper. Exam में आप पुराने वाली नहीं दिखेंगे. लिखेंगे, ठीक है। आपको पुराने वाली नहीं लिखनी एग्जाम में, राइट। सो आई थिंक दिस इज मोर देन इनफ फॉर टुडे। बाकी हम कल कंटिन्यू करते हैं। टोटल हमने 13 क्वेश्चन किए। सेकेंड पार्ट भी कर लेते हैं। वाई हाफ फील्ड एंड फुल्ली फील्ड ऑर्बिटल्स आर एक्स्ट्रा स्टेबल। देखो ये क्वेश्चन भी उसने पूछ ही लिया कि हाफ फील्ड की मैं आपको स्टोरी बताती हूँ। हाफ फील्ड में सपोज ये देखो, एक्चुअली इलेक्ट्रॉन्स आर नॉट स्टैटिक, दे आर डायनामिक, घूमते फिरते रहते हैं, इनको घूमना फिरना बहुत अच्छा लगता है। तो ये वाला इलेक्ट्रॉन इसके साथ अपनी पोजीशन को एक्सचेंज करेगा, इसके साथ कर सकता है, ये करते रहते हैं, ठीक है। देखा कितने एक्सचेंजेस हैं, 4। फॉर दिस 3 एक्सचेंजेस आर देयर, फॉर दिस 2 एक्सचेंजेस आर देयर, फॉर दिस 1 एक्सचेंजेस देयर। टोटल नंबर ऑफ एक्सचेंजेस आर 4 3 7 3 10 exchanges are there. Exchange energy is very high is the answer for this fully filled and half filled configuration, right? So today we have finished 13 question. Rest हम कल करेंगे, ठीक है। इन सब के आंसर्स आपने लिखने हैं और कल मुझे चेक करा देना, सेंड कर देना, ठीक है।